Hi guys, welcome back. Remember to send any more questions that you have to us through our Facebook line and our WhatsApp line. As Philippa has been saying, today we're doing first principles. And right about now, I'm going to be doing a question that was sent through to us by Philippine. So we're just going to have a look at that question and see how exactly we can help one another. And then remember guys, maths is food for the soul. So if you do it well, it will nourish every fiber in you.
Hello Tenfold, my name is Banele and I have a question I need help with. The question reads, if fx equals to x squared plus 2, determine fx from first principles. Thank you for your help. Bye.
Okay, thank you Banele for that exciting question. So let's just have a look at the question right away. The question reads, if f of x is equal to x squared plus 2, determine f of x from first principles. So what Philippa was just talking about right now is what we call the first principles. But now firstly we need to know what formula are we using when you're talking about first principles. So the formula we're using here will be f of x is equal to the limit of, remember, Philippa has been talking about when h is approaching 0, when h is becoming smaller and smaller. So hence I'm saying the limit is h approaches 0 of f of x plus h minus f of x all divided by h. So what we're doing here is this is the gradient of a tangent to that particular line that we have there from using the first principles that we're talking about here. If f of x is equals to that, before I can actually substitute there, let's just do it bit by bit. So what you're going to look for here, you're going to say f of x plus h is equals to, looking at that question, wherever there is x, I'm going to substitute x plus h. So this is going to be x plus h all squared plus 2. And then also this, if I substitute it, it's going to give me x squared plus 2hx plus h squared plus 2. Remember foiling out your binomials. And then the last one is f of x there that I have there. So what I'm going to substitute on my formula is going to be equals to, so going back to this particular formula that we have there, the limit of, please remember to include the limit, never use these lines. Normally people use those lines just to show that it is continuing from what it was. So right now, we're not using that. So this is going to be x squared plus 2xh plus h squared plus 2 minus the whole thing, which is x squared plus 2 all divided by h. So guys, let's have a look at this. What I've just done right now is I've just substituted in the formula f of x plus h. But what that means is wherever there is an x, you're substituting x plus h, and then you're going to substitute you're going to subtract f of x, which is the actual formula that you are dealing with. The goal here, from here, will be to get rid of h. Why? Because we said h is getting closer and closer to 0. But remember, we cannot divide by 0 because that will make it undefined. So the goal here is to get rid of the denominator that we have here. So let's just go back into it and have a look at what exactly I am saying. So this is going to be equals to, remember I said include your limit. H is approaching 0. So here, simplifying, this is going to be x squared plus 2xh plus h squared minus, this is going to be plus 2 minus x squared minus 2, all divided by h. So looking at like terms here, I'm going to say this here, and that is a like term, also that and that are like terms. So then they're going to be 0 because there's a minus there. So what I have here is going to be equals to, remember to always include your limit, the limit of h approaching 0, that and that is 0, plus 2 minus 2 is also 0. So I'm left with 2xh plus h squared divided by h. Now at this point, guys, you always need to look at what is it that you have and what is it that you need to do. From here, this is what we call one type of factorizing. We have 3 types of factorizing. It's using binomials, it is grouping the like terms, and also taking out a common factor. So this is the 3rd type in these 3 that I just mentioned. So here we're going to look out for the common factor as means of factorizing this particular problem. So this is what I'm going to have. Looking at what I have here, I'm going to have the limit of h approaching 0. My common factor there will be h. So I have h into 2x plus h all divided by h. Then this and that will divide each other. Please don't say they cancel out. Remember, if I cancel out something, it becomes 0. Ngabs, it's gone. So we can't say they are cancelling out. And then this will be the limit of h approaching 0 of 2x plus h. Remember, we said h is going closer and closer to 0. So the final answer will be 2x plus 0, which is equals to 2x. Now, guys, please have a look at what we just did right now. So what I just gave you right now is you trying to do what we call first principles. Doing first principles means you're using the formula that we are dealing with, which is f prime of x is equals to the limit of h approaching 0, f of x plus h minus f of x over h. So that's the formula that we're using when you're talking about first principles. After this, Julian is going to come through with a question. Just hold on. I'll see you just now.
Hey guys, welcome back to the show. I hope you've been enjoying it. We got a really great question from Lutando today. The question looks at a whole bunch of concepts that you're going to be looking at next week, but we are going to start looking at some of this stuff now. It just gives you a bit of a routine, or like a bit of a preview of what you're going to get into next week when we look at the questions based on calculus, maximization, and calculus graphs. So let's have a look at what the question has to say.
Hi Tenfold, I am Lutando Ndibongo and I'm sending this video from the East Rand. So I've got a question here that I'm struggling with and I was wondering if you guys can help me out. It reads, the sketch shows the parabola y is equal to f of x. A, determine the gradient of the parabola at the point where x is equal to 1, and B, determine the equation of the parabola. Here's the question. And I'd like to send a shout out to my mom and my friends. Thank you so much, Tenfold.
Okay, Lutando, thanks for that question. It's a really great question, guys. There's a whole bunch of concepts that you have to look at when you deal with this question. There's things that involve functions. There's a whole bunch of things on gradients that it brings in calculus principles. So let's have a look at what the question is exactly. So the question says, the sketch shows the parabola y equals f of x. Okay, so we don't actually know what this function is, but the parabola is drawn for us over here. So we say y equals f of x, and we've been given 2 points. We've been given the point 1 and negative 8, and we've been given the point 1 plus h, and that tells us, well, when x is equal to 1 plus h, we get an output value of h squared minus 2h minus h. And the first question reads, determine the gradient of the parabola where x equals 1. Okay, guys, so what we have over here, we want to determine the gradient where x is equal to some sort of value. So if we've got a curve and we draw a straight line, we want to determine the value of that straight line where x is equal to 1. And it says here on my sketch that where x is equal to 1, we get an output of negative 8. Okay, guys. So when it comes to this is a principle that you're going to deal with in next week's show when we get to calculus and calculus graphs. We've been finding the limit as h approaches 0 for a certain part of the graph, and that actually gives us the gradient of that graph at that point. Or if we get a value, or if we get a whole bunch of, we get a function value for that point where h tends to 0, we get a function that tells us wherever we are on that graph. It tells us all the gradients on that graph. But now we don't want for all the values, we just want to where that point is equal to 1. So let's go about doing this. If we take the limit as h tends to 0 of our function, so remember from the previous first principles we have f of x plus h minus f of x, and we divide all of that by h. So this formula over here, if we take the limit as h tends to 0, we actually get the gradient at that point. So we get the gradient at x, okay, for all values of x. But we don't want the values of x, we want where x is equal to 1. So let's substitute in what we know. I'm going to just continue over here. So we're going to have the limit as h tends to 0 of f of x plus h minus f of x divided by h. That's going to give me my gradient, but we want it where x is equal to 1. So we're going to substitute in what we know. Remember, we always take the limit as h tends to 0. We don't stop writing that down until we actually take this limit over here. So we're going to have then f of x is equal to 1. So we're going to have 1 plus h minus f of 1, and that's going to be divided by h. Okay, guys, so what we have over here, we've just written down a formula for all the pieces that we need. And if you look very carefully at our graph, we actually have these values already for us, so we can just substitute in what we have based on our graph. But we have to look very carefully at our diagram when we do this. So if we look at our diagram, the first thing we're looking for is f of 1 plus h. So if we go up and look at our diagram, already we have the value of 1 plus h for x, and if we have f of 1 plus h, we get an output value which they've given to us as h squared minus 2h minus h. So I'm going to substitute this in for 1 plus h. So again, we're going to write down the limit as h tends to 0. We have then f of 1 plus h, and that gave me an output of h squared minus 2h minus h. So we have h squared minus 2h minus 8. And then we're going to subtract my value where f is equal to 1. Now if we go back up and look at our diagram, we have 1 and my output value is equal to negative 8. So f of 1 gets me negative 8. So I'm going to put this in brackets. It's really important that you keep your brackets there so that you don't make this sign error when we distribute our negative in. Again, we carry on. We write down our limit as h tends to 0 of h squared minus 2h. Now this is going to be minus 8 plus 8. So that there is actually going to just cancel out. So we can strike that through. And we just left with division by h. Okay guys, so remember, when we are busy dealing with some of these calculus problems, okay guys, when we're dealing with some of these calculus problems, we always want to try and get rid of the h in the denominator, because if we have to substitute 0 in with h, we're going to get undefined and we don't want that. So the way we go about doing that is we factor out an h, hopefully it will cancel out with the h in the denominator, and then we can substitute our value for 0 into whatever's left over. So in doing so, again we take the limit as h tends to 0. We can factor out an h. We're left with h minus 2, and that's all divided by h. Okay guys, so what I was saying previously, my h in the denominator divides nicely into the h in my numerator, and then we left with my limit as h tends to 0 of h minus 2. Okay guys, so it gets to this point where we can actually then substitute in our value for h, which is 0, and then we end up with a value of negative 2. So what that tells us, guys, so this negative 2, what it tells us is at the point where x is equal to 1, we get h is equal to negative 2. So that's actually the gradient at that point, which is negative 2. Now let's see if this makes sense. If we go up to our diagram over here, if we have to make a tangent or draw a tangent at this point, we can see that this gradient over here is negative. So that means that this negative 2 makes sense to us, that the gradient is negative. Guys, we're going to move over to the next question over here. So the next question says, determine the equation of this parabola. Okay, it's a very nice question. At this point over here, we have f of x, well, f of 1 plus h. Okay, guys, so what we've been given in this diagram over here, we have f of 1 plus h, but we don't want f of 1 plus h. We just want f of h, and then we can substitute our values for x in, and that'll be the equation for this parabola. So the way we do that is if we've got 1 plus h and we want to get rid of the 1, we just subtract 1 from that x value, but we have to do the same for the output values as well. Let's show you how this is done. So we have f of 1 plus h, but we don't want 1 plus h. We just want f of h. So what we're going to do is we're just going to subtract 1, and that gives me an output value of, not f, it's just going to give me an output value of h Now remember, we subtracted 1 from this side. So wherever we have an h, we're going to subtract 1 then as well. So we're going to have 1 minus h squared minus 2 multiplied by h minus 1, and then we're going to have minus h. So guys, what we've just done over here is we've just transformed this equation that we have. We've been given 1 plus h. We now just want h by itself. So all we're going to do is simplify this, and we're going to finally get the equation of the parabola. So we're going to have then that f of h, which is what we're looking for. This simplifies to f of h. We're going to have h squared minus 2h plus 1. Then we're going to have minus 2h plus 2 minus 8. If we simplify this a bit further, we have f of h. We're going to have h squared minus 4h minus 5. Okay guys, so if we just substitute in our f of x, we have x squared minus 4x minus 5, and that there is the equation of our parabola. Okay, Lutando, thanks very much for the question. Guys, I hope you got a whole bunch of concepts over here. You can see how your functions is going to help you. The idea of first principles helping you get to the gradient of the equation, that's also going to help you. And this was a really lovely question. It brings in a whole bunch of concepts. So guys, we're going to be right back. Stay tuned, and we're going to carry on with more questions.